Hello and welcome to Quantum IAS. Because of some reasons, we were not posting the videos on time on the YouTube, but from today onwards, we will be posting regularly on the YouTube. Right now, also one more thing, you can see on the screen that something is written over here already. So I have recorded this video earlier also, but due to some tech error, the video was corrupted. Right. So I will be reinstating whatever I have said in the previous video. So the first question start from the rest pi mesons come to rest, disintegrate into muon and neutrino of rest mass 0, so that the kinetic energy is this much this. So this question is taken from the relativistic mechanics. You can see that. And first thing what we need to focus that this is from the decay process that is mentioned in our syllabus. And whenever we are in decaying, we have to write two things into introduction. First is the conservation of relativistic momentum, and the second is the conservation of relativistic energy. And we know that this integration can take place any direction. So considering it to be isotropic disintegration, right? We are solving these questions. So if you mention this keyword, that will be give a good impression, right? What you will write in the conservation of relativistic momentum? Same that you have studied in your classes. Again with the energy, right? This is what we can write in the equation format, that the momentum before this disintegration will be equal to the after disintegration. Same goes with the energy. Okay. Now, meson of rest mass pi comes to rest. That it is at rest, that means it will have only rest mass energy. It will not have any kinetic energy. It disintegrates into muon of rest mass mu. That means it will have rest mass energy at as well as the kinetic energy. Neutrino again has zero rest mass. That means it will have only kinetic energy, right? If you put these things, you will get that if it was at rest, then the initial momentum will be zero. That means P mu is equals to P neutrino. It will be equal and opposite. So as far as magnitude is concerned only, you can write P mu is equals to P neutrino equals to P, right? Now let us talk about what the energy they will have. So E pi is at rest, so it will have only rest mass energy pi c square. It will have the complete energy, right? Kinetic plus rest mass, and it will only have the kinetic energy, that is Pc. Now, if you minus E mu square minus E nu square, that means P square C square plus mu square C square minus P square C square, you will get mu square C square. A minus B ka whole square, we know that. We write A plus B, A minus B, and A plus B know that it is pi square C square. So if you see here, E mu minus E nu become E mu minus E nu become mu square C square pi, and this we know that this goes to pi square C square. If you add both of them, it will be 2 mu E mu, this term इसको इधर ले जाएंगे, half mu square C square pi upon pi C square. And this E mu is what? Is it the total energy of the mu1. So it will be equals to the rest mass energy of the mu1 plus its kinetic energy. Let's take kinetic energy equals to T, and rest mass energy will be equals to mu C square. So T will be equals to this component minus mu square C square. If you further simplify it, you will get your answer, that is pi minus mu square C square upon 2 pi. So as far as the conclusion of this question is concerned, you can directly mention the application, right? Because decay is mentioned in our syllabus, you can write it is useful in particle accelerator experiments, studying natural forces, weak forces. We all know that we will study in nuclear and particle physics, structure of the universe, medical imaging. So these things you can write in the conclusion. In the introduction, you need to state these two laws. Okay, that's all for this question. Moving on to the next question. Okay, one more thing. This is the description of the new batch that we are launching from the 1st March 2023. So from the 1st March 2023, this is the first batch, cohort 1 for UPSC 24, right? And in this, we will be having live and interactive classes, and that too are updated. That means the previous classes that I have recorded, it was the first official recording of the Quantum IAS, and it was done in 2020s. Right now for 2024, 4 years later, the pattern has slightly changed. There is a lot more focus on the numericals, and the scope and the things that I have learned in these journeys through various students, that will be incorporated in these lectures, right? And also in this lecture, there will be daily practice paper, right? That will be having multiple component, like assignment will be in daily practice paper, answer at practice question will be there, right? Numerical guidance, NGP questions will be there, right? So all these things, whatever that we have done so far, that will be combined in daily lectures, and that will be done on a daily basis. That will be live and interactive classes. Again, we will be solving this year 2000 plus numericals, right? Earlier we have solved 1500 plus numericals. This year we are going to solve 500 more numericals, so that the basic gap will also be maintained here. Also 800 questions. Earlier we have solved 500 plus questions in our classes for a question answer format, model answer format, that we are seeing here also in the daily answer writing program. This year we will be solving 800 plus question, right? Year-long test series, again it will be available weekly test and the test series. Along with this, handout and updated notes will be given. Again, the lectures are updated, so notes will be also updated now. And handout will be given for each and every module, right? Handout will not contain the derivation part, right? Handout will be containing the value addition part that will be useful in writing your introduction as well as the conclusion. So you need not to worry and search everywhere else, right? Again, one more, that is the new thing that we are introducing here, mentorship and hand-holding support. Now, till now, we will having the mentorship support, right? That if a student want to ask any question on the WhatsApp, Telegram, they can ask. If a student want to discuss its strategy, its preparation level, whatever he wants to or she wants to ask to the mentor, they can ask. There will be not a two-way communication, that mentor is not going to ask those students that what you are doing. But this year we are going to launch our hand-holding support, and that too on the weekly basis. On a weekly basis, based on the lectures that we have provided, the test we have created, we will be having your evaluation parameter every week, and each student will be called every week, and there will be a telephonic conversation with the student, that what we are doing and what you have done, right? And what else we can do for you, right? So all these things will be in the next foundation batch, that is for 24. And this year we are starting with the quantum mechanics, right? Most of the students start that we want to study paper 2 first. We know about mechanics, we know about aeronautics a bit, but we scare from the paper 2. So we will starting from the quantum mechanics part, right? Modular course also this year we will be introducing for quantum mechanics. That details will be out soon. Okay. Coming to the next question. Next question was based on the Doppler effect in the light. So Doppler effect in the light, again, it will be changing the frequency due to the relativistic motion, relative motion between the source and the observer, that you can write. So instead of red, we are seeing the green. This is what they have written, right? This is the excuses that we make to the traffic police, right? When we jump the red signal, that I have seen it was green, now it is red. So let me tell you, if you are making these excuses to traffic policemen, what should be your speed to say that I have seen it green, but it was red? So in introduction, you have to write about the longitudinal Doppler effect, right? And the blue shift, because instead of red, it is seeing the green. Okay, that too you can write. In the conclusion, you can write about the application of the longitudinal Doppler effect, that is the measuring this distance from the earth, right? Using the red shift and blue shift, we can measure how far we are from any celestial planet. Radar system, weather forecasting, military surveillance, and air traffic control. These are the conclusion that we can use over here. Okay. Instead of red, we are seeing the green. So green will be lambda dash and red will be lambda naught. We know the formula. If it is approaching the source, we can write that lambda dash equals to lambda naught 1 minus Vc upon 1 plus Vc. Here we need to understand that the motorcycle, the speed of motorcycle will be much lesser than the speed of light, that is less than 1. So we can use the binomial approximation. Again, these things are pre-written because the previous video was corrupted. That's why we have to see like that. So lambda dash square can be written as lambda naught square 1 minus Vc upon 1 plus Vc. And it can be written as 1 plus Vc over minus 1. So it is equals to the 1 minus Vc square. So approximately lambda dash can be written as lambda into 1 minus Vc. If you can move this lambda here, you can find out the V is given as lambda minus lambda dash. lambda we see. Okay, lambda or lambda naught same. Uh, lambda naught, lambda naught, lambda naught, lambda naught, lambda naught. Okay, and the answer that you will get, it will be 3871 kilometer per second. That's a two very high speed. So we cannot make the excuse while crossing the red light that I have seen that it was green. Okay, so that's all for the day. And what I need to tell you that due to some issues that we are not posting the videos, but from now onward there will be a regular video on the YouTube as far as the DAW is concerned. Okay, thank you. Bye bye.